Just for the video, we are on page 31, and we are looking at Z-scores as a review, and we're doing finding the percent per 2. So we have a mean and we have a standard deviation. Based on that, I know there's more to the question, but the first thing I want to do is draw my curve. So my mu goes in the middle. I'm going to divide this into 4 parts. Divide this into 4 parts. And might as well put in my percents. When you guys get your exam, you will get that sheet that's got the percent, so you don't have to memorize them. So that part's the same every single time, and what changes is the numbers we throw across the bottom. So the middle part is our mean. And then each one of these boxes represents one standard deviation of the data. So our standard deviation is 8. So I've got 88, 96, and 96 plus 8 should be 104. I'm hoping that someone will scream at me, or at least wave me down if I screw this up. 78 minus 8 is no. Should have left that to see if anybody would talk to me. 72, 64 minus 8.
56.
Thank you. I was going to get there, but it's good to know I have friends out there. Okay, cool. So we got minus 8, minus 8, minus 8. If you're wondering, what do you need to know for your exam on Friday? This, definitely you need to be able to label. Okay, so then, now I'm going to read the rest of the question. Pat scored a 76. Okay, right away I know it's messed up. Well, it's not messed up. I'm going to have to do a Z-score. If my numbers were the ones that are down here, what I call the magic numbers, I don't have to do a Z-score. But 76 isn't there, and 94 isn't on there. So we got to do a Z-score. But before we do that, I'm going to estimate where these are. So if this is 72 and that's 80, I'm just going to be lazy. I'm going to say it's about there. And I'm going to label it as 76. And then 94, I don't know, somewhere over here. Oops. And you certainly can, every single time, just put it in the middle and consider it good enough. So what we want is the percent of the individuals that would score between here. So estimate, I know it's all of the 34, plus I've got part of this one. I don't know, I'm going to guess half of it, 17, plus that one, guessing 6. So 34 and 17 and 6 is, well, whatever that is. I'll add it up later. There we go. There's my estimate. I would like you all to do the Z-scores now. So Z is equal to X minus mu over sigma. I want you to do that for 76. And for 94. So I'm going to pause the video and give you a chance to do that right now. Okay, let's go through this. So X is my data number. So this is 76 minus. So for this question, what is the mean? Jose, what's the mean on this one? Jose, you there? All right, Miranda, help us out. What is the mean on this question? Oh, yeah, what's the mean?
It's 80.
It's 80, and what's my standard deviation?
8.
Right. So Z, 76 minus 80 is minus 4 over 8. Z score is minus 0.5. And I always put my standard deviation to remind myself what the heck I'm doing. All right, Dominique, talk me through the next one, please. What number goes first?
94.
All right, keep talking. Minus
80.
over
6 or 8.
I know, that's just me. Your exam will be typed. You don't have to deal with me and my sigma signs here. All right, what's 94 minus 80?
I don't know.
Okay. Driana, help her out.
Oh, 14.
14. All right, 14 over 8. So Z is equal to 14 divided by 8, 1.75. Before I go further, I want to see if my answers are reasonable. So my first one, whoopsie, I lost my decimal there, says it is half a standard deviation below the mean. So here's my mean, and I'm below it. I guessed it was there. Sounds good to me. And my other one is 1.75 above the mean. So here's my mean. There's 1 and some more. Yep, those seem reasonable. And it also allows me to make sure my signs are correct. But that's not what the question asked for. Rachel, what is the question asking me to figure out? It's not asking about standard deviations. What is the last sentence asking us about? Sammy, you want to help her out?
It's asking about the percentage between Chris and between Pat.
Okay, so there's our key. We are not done. Although, you know, on a 10, I don't know, say 10-mark question, we're half done. We've drawn our picture. We've got our standard deviations. So where, Cleveland, your turn. Where do we find percents? How do we convert this stuff into percents?
We divide it.
Oh, so close. Ayla, do you know how to do it? We have to look at something else.
Z-score.
Wow, your voice is weird today. Yes, we need our Z-score. Whoopsies, upside down, my bad. We need the Z-score table. Again, when you guys write your exam on Friday, you will have this. I would bring a highlighter. So we need to convert our standard deviations into Z-scores. If these were whole numbers, we could just peek on the charts and pull it from there, but they're not. So negative 0.5. Ooh. Let's see here. So I go on my chart. Sorry about that. There. So I got negative 0.5. Sorry, I'm just disorganized this morning. I can't find, there we go. So it's going to be in this row somewhere. But I need a second decimal place, negative 0.5. Cleveland, what can I add? What can I put here? Michelle,
I
how
was
about
looking
you?
for my paper while you were doing that. Sorry.
Okay, no problem. Hey, Michelle, what can I put here?
A 0?
Yes, we can put a 0 as a placeholder. So that tells me at 0.5, we're going across. And we're going to use this column going down. So it's 0.3085. And I always write from table on there, so I remember where that came from. And I need to convert that into percent. Clarissa, what do I do to this to make it a percent?
I don't know.
Okay, well, Rena, help her out. How do I go from a decimal to a percent?
You divide by 100.
Oh, so close. Backwards.
Times by 100.
So 30.85%. You can also see that if that whole chunk is, whoops, if you can see what I was pointing at, if this whole chunk is 34, this would be about 30. It's wonky because, again, this curve, it's a curve, so it's not exactly half. So this tells us, and this is key, whoops, will make more sense. This is telling us how much actually is in this area. That chart always, always, always gives you the data to the left. Not data, percent to the left. Always. All right. So what we just did was this area that I sketched here. Now 1.75 standard deviations. I'm going to stop for a little bit and let you guys do that. Look up the number. All right, Renee, what column, which one of these numbers do I need to start or to highlight to do 1.75?
1.7.
Okay, so we got 1.7. It's going to be that row. What number, whoops, it'd be helpful if I had that on the screen for you. I'm sorry, everybody. There we go. And what column across the top do I need to color in?
0.07.
Nope. I'm doing 1.75. So I've got the 1.7. Cleveland, what's the end?
0.05.
There we go.
Oh, I did it wrong. My bad.
Does it make sense now?
Yeah, it does.
Okay, cool. So 95.99, or sorry, 0.9599. 0.9599.
Times it by 100.
And that is going to give me 95.99%. Well, now I'm kind of screwed. Whoops, sorry. That's on tape. My bad.
You
I
said
have
that-
2%. What am I going to do with it? Well, I'm going to make a terrible mess with my picture here. My first answer, this 30%, is this part of the graph. So I know that over here, that part is 30%. This 95% represents, and it's key, all of that stuff. Oh my goodness, that looks awful. So shadow. What color, and I'm just looking for color right now, is the part in between Pat and Chris? Is it yellow, is it green, or is it blue?
Blue?
Yes, exactly. But how in the world do we figure out the blue part?
I would, well, first you have to subtract the 95 from 100, which would give you 4%. And then you could add the 30.85% plus the 4.01%. And then you would take that away from 100, which would leave you with 65.14% in between Pat and Chris.
I think I followed that, but I'm gonna just do this. I'm just gonna subtract, because if that's 94 and that's 30, the difference in there is gonna be subtracting them. And I bet it's exactly what you said, Samantha. 95.9, whoops. 95.99 subtract 30.85 is 65.14. So depending on your question, if you have the word between, go with subtraction. The only time you would add numbers together is, imagine you had a graph like this, or whatever it is, and the stuff you cared about was here. And here. If you were doing the end parts, then you would add. But if you're not sure, it's probably going to be subtract. This question's pretty rare. You could also just both add and subtract and then see which one fits. Hey, I have a question. Wait a minute. 95.99 plus 30.85. Okay, I just got 126.84. So I'm thinking, oh, sorry, you got Claire there, that adding those two numbers together doesn't make any sense because it gives us over 100%. There's a kind of cheap and dirty solution to it. If you're not sure whether to add or subtract, try both. And one of them will probably not work. Okay, flip the page, excuse me. So this was finding a percent. Now, we're going to look at finding values, which is slightly different. I'm going to have to do a little bit of backwards work. All right. And I stole these out of the textbook because I didn't exactly know how to make up these questions. Athletes should replace their running shoes before the shoes lose their ability to absorb shock. Running shoes lose their shock absorption after a mean distance of 640 kilometers and a standard deviation of 160. Okay. At that point, I'm going to stop reading my question. And I would like you all to draw the graph, draw the curve. And I will pause the video for a sec. Turning the video back on. All right, so we're getting there. I drew my curve frequency. So how often does that happen? Now, 640 plus 160, 800 160 should be 960. Plus 160. 120. 640 minus 160. 20. 160. You can overwrite my answer key, make sure I'm good. All right, to get full marks on your thing, this should be kilometers. Units. He's got the little one. There we go. All right, so kilometers here. Distance for losing shock absorption. So that, although not very pretty, would be a perfect graph. I'd be looking for frequency, a title, units down here, numbers, percents, and all that. You don't have to do that on this stuff, but make sure when you write your test, or maybe if you're handing stuff in, that would be good. Anyway, so here's where the question is weird. All the other ones we had, it was, we'd have some numbers and then we'd find the percent. This one's different because we're looking at, we're given a percent. So it's kind of going to have to do the question a little bit backwards. So first of all, let's see if we can understand. Sorry. Your pictures are covering up part of my screen and it's weirding me out. Okay. So we need to figure out 25% of the people will replace their shoes. So if we think about this, this represents when 0.15% of the people will replace their shoes before 160 kilometers. Okay. Some people are going to replace them when they're at, they've run 320 kilometers. Some at 480. So an easy way to say is at 640, half of the people will replace their shoes. But we want 25%. So we know 25% is going to be somewhere down here. But if we start adding 0.15 plus 2.5, Jose, how much is 0.15 plus 2.35? Can you do that in your calculator? Miranda, how much is it?
What was the question again?
Oh, there we go. 0.15 plus 2.35.
0.15 plus
Yep.
16.5?
No. I think you punch something in backwards. Try it again. 0.15 and plus 2.35.
2.35. It's only 2.5.
Perfect. Okay.
You were wrong.
And we are looking for 25%. We don't have enough. So now we need to add on, excuse me, our next percent is 13.5. You still there, Jose? How about you add that? 2.5 and 13.5.
$16.
Perfect. What number are we looking for, though? We're looking for 25. We're not there yet. Okay, one more time.
So
You add
16.
Plus 34.
Are you asking me or somebody else?
Well, you're on a roll.
51.
It's going to be 50.
That's it.
All right, cool. So that's too much. So our line where I'm going with this is somewhere here. Because this much is 16%. That's 50. That's too much. So we need to figure out and that yellow area needs to be 25%. So in case I lost anybody, what I was doing here is just trying to get an idea of where I should draw my line. Before we had numbers and we went to percents. Now we're starting with a percent. So we need to consult our handy dandy Z-score. And this is the part where it's fun. We are going to look for the number. Oops, I forgot. How do I go from percent to a decimal? Miranda, what do I do with the 25 to make it a decimal?
Divided by 100.
You bet. So we are going to look on our chart, and you're looking at the little boxes. And you're going to look for 0.25. All right. Well, there's 0.1. That's not enough. Oh, all right. If we look at negative 0.6, there's 2483. Yeah. And 2514. Those are going to be the two numbers that are closest. Now I'm going to go back to my question for a sec. He wants to know when 25% of the people would replace their shoes. So we're always going to go down. So we're going to go less. So this is the one I care about. Truthfully, on a test, if you did either of these two numbers, I'd mark it right. But we're going to go less. So now we read backwards. So if I want this.
Hello. Oh, hi. I'm sorry for the pronunciation. Shadok? Shadow? Oh, Shadow. Okay, sorry. No, that's okay. Michelle. Hi. I'm calling on behalf of Saskatchewan.
There we go. I'm going to mute Shadow there. Okay, so we go there. So negative 0.6. And then we go up. And we got 0.08. So this corresponds to negative 0.68. So that's where the negative 6 part came from. The first part came from here. And then we read across and up to the top. Whoops. And that's where the 0.8 came from. And I should just say right now, again, there we go. I know when I did the video, I went the other way and I used 0.67. It's fine. So what is this? Is that percent? Anybody? Not percent. It's my Z-score.
How did you get to 0.6? How did you go from 0.5 to 0.6?
Okay.
Yeah, you lost me there too.
Okay, here comes the magic. And thank you for asking. Because, you know, if you don't ask, the shy people will never know. So let's start again. We are looking for a number close to 0.25. And I think when I do this on the test, I will just make it exactly one of the numbers to make our life easy. So I'm looking in all my little boxes, and I want the number that's closest to 0.25. So I got 0.2451, and I got 2483, and then I'm too big. Sorry, keep putting stuff at a weird angle on you. So this is the number I want. That's the closest I'm going to get to 25% without going over, or 0.25 without going over. So then I need to read backwards. I get my first number, negative 0.6 from here. And then I go up and grab my last digit from up here. And that gives me my Z-score. You know what, we're gonna stop for a second with the question. We're just gonna practice for a sec. We'll come back to the question in a minute. All right, I want to convert. So, whoops. I'm sure there's room somewhere on your page to write this. Find the Z-score for 0.0197. I want you to find the associated Z-score for this number. So you gotta look on your table and find it. Has anybody found it? Which row is it in?
Third.
It's in, so I got I don't know how to say it. Like, so
Okay.
I got it negative 2.6. That's what I got. But I
So-
don't know how to tell you how I got there.
So you find the number first, and then you look at which row it's in. By the way, in math and stuff, rows are always horizontal, columns are this way. I feel like I'm blessing you all. Bless you. There I am, I blessed you. Okay, so we look here first. So we're gonna go to see which row we're in. So it's negative 2, whoops, sorry, yeah, 2.0. So I grab this one and this one. And then you just go up and you write whatever that one is at the end. So the first two come from the row and last one comes from the column. Let's try that again.
Do you always start on that side of the table?
No,
Like, how do you know when to use the other side?
I'm about to. How about let's do 0.793. I lost it. 7939. Okay, find the number. I sense I'm going to do a separate video to practice this. So look on
on the previous question, like the 0.0197, how did you get negative 2.06?
Okay, so I find my number. You gotta find the number first, and then you read over to see what column it is, and that's your first two. Sorry, what row it is, and then the 6 came from up there.
Oh, I see. Okay, thank you.
Okay. So everybody try this one. And hint, it's going to be on the other side. So I just realized if it's less than half, it's on the left-hand side. If it's a number more than half, it's going to be on the right-hand side. So I need 7939. Ah, now I lost it. Okay, there it is. So you're looking for the number in the box. And then I'm just going to do connect. Right? It's the opposite of what we were doing before. Instead of finding this, we're getting the number and going the other way. So it's going to be 0.8. That comes from there. And then a 2 from up there. We just add that last number on. Yeah, there's definitely going to be a video about how to read a Z-score. Okay, one more. Rihanna, did you, I'm going to start one back. Do you have the table with you?
Were you talking to me?
Yes.
Oh, yes, I do.
Okay. Have you found 0.9932?
No, I didn't.
Okay. Can you find it?
Would it be on the positive side or the negative side?
It is on the positive side.
Okay.
They do go kind of in order. Have you found it yet?
No.
No. All
I
right.
found 931.
Okay, go the next one.
Oh, okay.
All right.
I found it.
Okay, cool. So we've got the number. Now, what row is it in? Go back.
2.3. 4. 2.4.
2.4. So, and then we have to go up and get the last number. So 2.4.
0.7.
Yep. Now, if you guys are getting weirded out, you know what? I just realized what you can do. You can go 2.4 plus, whoopsies, 0.07. You can just add this one and this one, and you'll always get your answer.
Oh.
I just realized that. It's like, whoopsies. Okay, let's get back to our question. So we got as far as we found it on the table, and we have a Z-score of negative 0.68. Before I go further, right, this is, oops, let's erase that because I'm going to run out of room. This is standard deviation. I want to make sure that my picture makes sense. So it says my line is at negative 0.68. So this is a line I was thinking of. And yeah, that could be 0.68 standard deviations because that's -1 there and we're partway. So that's cool. So our number looks good. But our question is asking about the distance. So we have a z-score and we need to convert that into a distance. Well, I'm not sure how to do it, but let's use our z-score formula and maybe it's going to help us. All right. Rachel, do we have a z-score at this point?
What was that?
Do we have a z-score? Have we figured out the z-score so far?
No.
Okay, close. It's right there. So negative 0.68, whoopsies, I don't need that, is equal to, if we look at the question, Rachel, I'm going to pick on you again. Can you tell me what the mean is? Okay, 640. Cleveland, what goes on the bottom? What's our mean?
I thought that one was 640.
Oh, sorry, what's our mean? Sorry, what's our standard deviation?
160.
All right, so that goes on the bottom. So the only thing we don't have is that x part. And that's normally the data point. So we're okay. And I realize I erased the negative thinking I screwed up, but no, it's supposed to be there. So now we're going to solve our equation. I'm going to put it over 1 because I like to cross multiply. So 1 times x minus 640 is equal to negative 0.68 times 160. And I only cross multiply because I hate fractions. I'm going to multiply by 1, but basically I'm just going to end up dropping my brackets. And this is negative 108.8. So when I multiply these through together, I need to solve my equation. Ayla, how am I going to get the x all by itself? What should I do next? Ayla, are you there? Michelle, what should I do next?
Subtract.
Well, I'm subtracting already.
Oh, divide.
Nope. Keep going. Somebody help her.
I was writing down the question.
Oh, okay. Sorry.
You do the inverse of 640 on both sides.
There
Sorry.
we go. So I guess in a way we are going to subtract or add. So we're going to add, that's going to disappear. X is equal to, but I got to be careful. So 640 minus 108.8. This gives me 531.2. And that was an awful lot of work. for one little bitty question.
That's the answer?
Yes, and to see if we're remotely right, if we look back at our picture, which is why I always draw my picture, we say the answer is about 530. Well, our graph here says between 480 and 640. Yeah, that could be 532.
Cool. I think that's how you do a bonus question on the second hand in assignment. I couldn't figure it out.
It could be. I put in yeah, the bonus question was ugly. I know. All right. So I think we should take a break. So about 5 minutes or so, quick break, and let's come back and we'll do one more. All right, so I'm gonna stop the recording.